Chapter 10 Torque. This is a short presentation. Torque. Definition. Cross product of a force and a lever arm to a given axis. Forces change the translational motion of objects. The rotating counterpart must adapt to the rotational motion of the object about its axis. The rotational counterpart is the torque. In everyday life, we rotate objects about an axis all the time. Consider, for example, how we rotate a door to open it. First, we know that a door opens slowly if we push too close to its hinges. It is more efficient to rotate a door open if we push far from the hinges. Second, we know that we should push perpendicular to the plane of the door. If we push parallel to the plane of the door, we are not able to rotate it. Third, the larger the force, the more effective it is in opening the door. The harder you push, the more rapidly the door opens. The first point implies that the farther the force is applied from the axis of rotation, the greater that angular acceleration. The second implies that the effectiveness depends on the angle at which the force is applied. The third implies that the magnitude of the force must also be part of the equation. Note that for rotation in a plane, torque has two possible directions. Torque is either clockwise or counterclockwise, relative to the chosen pivot point. Now let's consider how to define torques in the general three-dimensional case. When a force F is applied to a point P whose position is R relative to pivot point, the torque T around pivot point is T equals Rf. From the cross product definition, the torque T is perpendicular to the plane containing R and F and has magnitude, where theta is the angle between R and F. T equals Rf sine theta. R sine theta is the perpendicular distance from pivot point to the line determined by the lever arm. The greater the lever arm, the greater the magnitude in torque.